We're going to look at factorization of various types of quadratic functions. The first one we're going to look at is one that we've touched on before when we did expanding. When we've got the difference of two squares, or two things squared, we can recall a pattern, but we're going to apply it in the opposite direction. So a squared minus b squared equals a plus ba minus b when we factorize it. So we're simply just reversing the direction of that, and we're going this way. You might recall earlier on we went that way. It's about identifying the pattern and factorizing it. So this form here is expressed as a product of its two factors, and that's basically what factorization is, you might recall. An example of this might be 9x squared minus 36. We have two things squared here. You need to be able to identify what each thing squared is. So what squared gives us 9x squared? The answer is 3x. So if we have 3x and then we square it, we get 9x squared. What squared equals 36? 6 squared. So if we go and apply the pattern that we can see there on the left of the screen, 9x squared minus 36. So we've got a and b essentially, and we've got a plus b, which would be 3x plus 6 times 3x minus 6, and that's factorized. You can always check it to see if you get the original expression, and 3x times 3x is 9x squared. Then we have 3x times negative 6 is negative 18x, and do those two plus 18x, and we get minus 36. So that most certainly does work. So that's factorizing in the pattern of difference of two squares. There's certainly more, however. The next one is monic quadratics. You may have perhaps seen functions in the form of ax squared plus bx plus c, where a, b and c are real numbers. So we need to be able to factorize monic quadratics when a equals 1. It's a special case. So that's when a equals 1. So an example of that might be, keeping my color coding consistent, we've got x squared minus 2x minus 8. So that does fit the pattern. A would equal 1, so there's a 1 there, but we don't need to write it, so you'll typically not see anything in front of the squared there, but there is a 1. Alright, so I'm going to take it away, but just understand there is a 1 there. And b would be negative 2, because you could go plus negative 2. Alright, so it's plussing a negative 2, so b is negative 2. And same with c. C is negative 8, because it's the same as plus negative 8. So it does follow that pattern there. We need to factorize that into a product of its factors. One way of doing this is what's called decomposition of the middle term, or the decomposition method. Decomposition is breaking something down. So what we do is we work on breaking down the middle term, the bx term. So here's one possible way of doing that. So what we do is we write again x squared, and then we need to break this middle term down into two terms. We leave the third term as is. So the first and the third term are still there, but I have left some space. What we've got to do is play a little bit of a game, and we need to work out pair of numbers. Now this pair of numbers multiplies together to give the value of C, which is -8. So it needs to multiply together to give -8, and it needs to add together to give the value of B, which is -2. Can you think of two numbers that multiply together to give 8 and they also add together to give 2? Pause the video and have a think. How about -4 and +2? -4 times 2 is -8, and -4 plus 2 is -2. That works. And that guides us into how we decompose the middle term. We need to break -2x into -4x plus 2x. Notice how the overall value of the middle term is still the same. It's not like we've changed the expression. We've just changed the way it looks, and we've decomposed the middle term, but the overall value or the overall expression is the same. So what that allows us to do, and by the way, the 2x and the -4x can be written in either order, it's fine, as long as it's broken down. What we do is basically put up an imaginary partition between the first part and the second part. So we're going to look at the left of the grey line, and we're going to factorise those two terms that are there to the left of the grey line. The highest common factor of x squared and -4x is x. So x is the highest common factor, and if we pull x squared divided by x is x, and -4x divided by x is 4, so it's -4. Alright, now we're going to do the same with the two terms here on the right, +2x and -8, 2, +2, so plus 2 is the factor that's common to both, and that will leave x -4 inside. Now you know you've done this right when the two contents of the brackets here is the same, because that's a factor. X -4 is one of the factors. What we have is x plus 2 is distributed amongst x -4. So, or x and 2 is shared amongst x -4. So that means that the two factors, and you will get two factors with these, is x plus 2 and x -4. So that's where it all comes from. So you can see there with the color coding how the pattern works. So that's how we factorize a monic quadratic. Now for the final type. A non-monic quadratic is similar to what we just saw, except for a does not equal 1. It's usually a number, an integer normally, that is something like 3 or 4 or something like that. We've got something I didn't add earlier with these quadratics, of course. Not only in the case of a monic, we can't have a equal to 1. With any of these quadratics, we can't have a equal to 0, because that would knock out the first term and we would have a linear function instead. Not all quadratics can be factorized, by the way, but the ones we're going to concentrate on here in this section can. And there's other processes that we can use instead of factorization, but more about that in the future. This is just an important skill. Let's look at an example then of a non-monic quadratic, and we've got 8x squared plus 2x minus 15. Okay, so a doesn't equal 1 or 0, and we've basically got the same deal. We need to decompose the middle term, the 2x, into two terms. So the only difference between this when we're playing our little game is that you might remember two numbers to times together to get a certain value and two numbers to add together, same two numbers. So what we've got is we're still after two numbers that add together to give us the middle term, the b, that is, not the middle term but the coefficient of it, which is b. Two numbers that add together to be 2, it's positive 2 in this case. We want two numbers that multiply together to be not just the minus 15 there, but it's the product of these two terms, a and c. Now be careful, the value of c is negative 15, alright, because you can go plus negative. So c is negative 15 and a is 8. Alright, so what we need to do is, that's 8 times 15, which is 120, so it's negative 120. And we need to look at two numbers that add together to be 2 and multiply together to be negative 120. Now, a couple of tips for those who want to know some finer points to give your work some finesse and to make life a bit easier. When you look at the two things these things have to add to, you know the two numbers are going to be pretty close together because they're only 2 apart. They add together to be 2. One's going to be negative and one's going to be positive because when they multiply together they give a negative 120. So the magnitude of the numbers is going to be close together, but one will be positive, one will be negative. What about some combination of 12 and 10? Now 12 times 10 is 120, so one of them has to be negative. It's going to be the bigger number is going to be positive because it outstrips the negative to give 2. So that would be positive 12 and negative 10. So let's decompose the middle term, 8x squared plus 12x minus 10x minus 15. And remember, the 2x doesn't go away, it just gets devolved into two terms. Okay, so it's still the same expression. So we put our partition down and we look at the first two terms, we factorise them, we take the highest common factor out the front, which will be 4x. 8x squared divided by 4x is 2x. 12x divided by 4x is 3. So hopefully we can find another 2x plus 3 in brackets coming up. Alright, so if we want to get another 2x plus 3 factor, which is really what we should end up having, we need to take a negative factor out. So we're going to go minus here, and 10x and 15, we're looking at 5. Alright, so we want to take a factor of negative 5 out, so we've got a positive inside the brackets. So that's why I've written plus negative 5. I'm just going to take that away and write it as minus 5, the same thing. And let's check that. Minus 10x divided by negative 5 is positive 2x, and minus 15 divided by negative 5 is positive 3. That works. So we have two factors. We have 4x minus 5, which is distributed amongst, or shared amongst, 2x plus 3. And basically we can check our answer. 4x times 2x is 8x squared. 4x times 3 is 12x minus 10x, which is 2x. Negative 5 times 3 is negative 15, and that works. So there's 3 types of factorisation you must be able to do.